they say, well, if amplitude A is 4, right? And they say, why don't you just take the D to be -2, right? Just do what they say, right? So -2 for D, 2, right? Negative A is 4, cosine 2t, right? So now, like Noah was asking, what are you going to do next, right? You will isolate cosine 2t, which is 1/2, right? So now I guess that if I were to write 2x, then you see, oh, we did that before, right? That's one of the questions in a packet. But I mean, what difference it makes, right? T is unknown, just like the x, right? It's just that T has a meaning now. It's time, right? And it better be in seconds. But here's the catch. You have to get all the angles that you think that's going to make cosine become 1/2 in radians. Okay. So now what are they? Let's say 2t is that big angle theta, right? Can you guys tell me what angles so that cosine of it will be 1/2 in radians? Okay, so pi over 3, right? Now plus 2m pi. Would there be another possibility? Some 5 pi over 3, right? Niquin said that as well, right? Or 5 pi over 3 plus 2m pi. Now, let me pause. You guys all see how I got pi over 3, 5 pi over 3? No? Because cosine of an angle is 1/2. The easy possibility is pi over 3, right? But the hard one is when you use the unit circle to find, so yeah, you know what? I'll draw it over here. That unit circle, and you want cosine, which is the horizontal coordinate, right? So you'll be looking at a point here, let's call it P, right? It makes an angle, you guess will be 60 degree, right? So can you ask yourself that where would the other point be so that it will have the same exact horizontal coordinate as the P? That has to be right over here, right? And that point Q makes an angle of 60 below the horizontal line, right? But the way you address those angles in a standard position is you go from the positive x going around, right? But the first one is easy enough since 60 degree is pi over 3. Or you go all the way around and get to the point Q, right? That's 60 degree away from 360. So it'll be 300. But if you translate that into the radians, it will be 5 pi over 3. Now, you guys good with those two possibilities, right? Pi over 3, 5 over 3, with 2m pi added to them. Now, remind yourself what n stands for. Integers, right? 0, plus or minus 1, plus or minus 2, even plus or minus 3, dot, 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 right? So now, how do you get t? I mean, 2t is given, right? Don't you just divide out the t, divide out the 2? You get pi over 6 plus m pi, or 5 pi over 6 plus m pi. You guys all see that? The way to get a t? Divide out the 2, right? So now, are we ready to get all the solutions they want? Because I want the t to be within the first 10 seconds. I would say, I divide, by 2, then you get 5 or 6, right? So I need 10 seconds. I need decimals, right? I need this to the 10th, right? You said, I don't see any decimals. But what is pi? Pi is, yes, 3.14. Okay, so basically you get t equals, then you do the math, right? So if you want in the calculator, it'll be 3.14 divided by 6 plus n times 3.14 or 5 times 3.14 over 6 plus n times 3.14. All right, so be right back. All right. And n is just integers, right? So now do you know how to get all the value of the t within the first 10 seconds? Just keep trying, right? I know it's kind of tedious, right? Angle to 0, obviously it works out. Angle to 1, angle to 2, right? Until you get n's a bit too big that you're getting the t from either guy, right? Greater than 10, right? So now this is what you can try after class, because I do want you to get everything perfectly done for this kind of problem, so you can refer to, right, when you do the review tonight. So I'll tell you what t's are. T will be, I mean, just round up or down to the 10th place. 0.5, 3.7, okay, 6.8, 9.9. Now from the first general solution, and then we can also get 2.6, 5.8, oops, 8.9. So there are 7 solutions. All right, let me zoom out. Plugging in, plug in the values like 0, 1, 2, 3, stuff like that. Okay. You get points if this is one on a test. You still get points for like if the rounding's just very. Oh yeah, let me tell you how I'm gonna grade, the test. So if you're able to write down that equation, simply realizing that they told you what A's and D's are, right? 1 point for that. So now with or without a unit circle, it's not a problem. But I want you to see that, you did something about, the cosine function, and you told me that the t is in that general form, right? So I may give, 1 or 2 points for just the work, right? So now up to this point, right, or getting the t, 1 point for the equation, 1 point for, some basic algebra, right? 1 point for getting the answers in a general form, 3 points, right? So, I mean, it's very reasonable to assign you 2 points for a whole bunch of answers, right? So now Noah says that, hey, what if I get, 0.51, right? Or 0.6, 0.57, right? I mean, to me, that's close enough, right? If you're missing some solutions, you're supposed to get 7, but you get 5, I'll take a point off, right? Stuff like that, right? Yeah. Oh yeah, yeah. So just remember that here, everything up to this line. Okay. Say pure math. So it's not realistic. So you're not in the real world, right? If you're just doing the math, right? So, but you're fine in my class, right? So that's why you get 3 out of 5, right? But the remaining is the real world situation, right? And you do get 2 points for that. And I do want, in the ideal world, that you show me that you know all the solutions. How do you know how you will stop adding 360? Well, here, do you see that if you put n times 2 pi is 360, right? N could be any integers. That means in general, you never stop. Because any angles which is, off by a multiple of 360, could be 2, could be 3 times, or could be 4 times, of 360. They're all the same. So you need to tell me that n is any kind of integer, so you're including all possibilities. You don't stop. But in a real world situation, since I want the time to be less than 10 seconds, you see that you can only take that many value of n, say 0, 1, 2, 3. Right? So yeah, I don't want to get too complicated than it really needs to be. But what did you learn from this problem? Anything new? Well, not really. I'm glad you say that, right? I mean, I'm sure that you guys can figure it out, right? The last 2 points just by playing at the end, right? At least try it today, right? Make it perfectly down, then you'll be fine tomorrow. If you see problems like this kind, not necessarily this kind of problem, right? Or talking about oscillation stuff. But what I want everyone to be able to very confidently get to the math part, worked out perfectly, right? And the remaining, I mean, do what you think is reasonable, right? Ryan, you have a question? All the work is all correct, but like we messed up like a negative sign, and so we get like a negative. Where? It depends on where you messed up the negative sign. Okay. Well, then, maybe 1 point off. Okay. All right. Yep. No, I was dividing both sides by -4. All right. So now let me get to the quiz questions, because I see quite a few issues, small issues. So I'm not super worried, but if it's multiple choice, right, that might still mess you up. But therefore, now at this moment, then I'm assuming that you guys either has remembered identities, or you have to remember as many as you can, right? And you know the right strategy to deal with those identities. So now let's just deal with the most practical things, right? So all those mistakes I've been seeing so far in the past like a week and two, okay? When people come for the quiz, all right? Okay, what's the cursor here? Okay. I think that for some reason that those questions about identities in the quiz packet are the ones that probably bothers a lot of people. It's probably why people maybe didn't realize, they hesitated, right, before coming. Even though that, they probably realize they're ready, but they're kind of concerned about not being able to figure it out on site. Since now most of you have tried it, can anyone share with us among those 4 or 5 tips, which are writing expressions in terms of sine and cosine, factor out the GCF, right? Combining fractions or splitting fractions, right? Forget about the 5th one, talking about like multiplying the conjugate or whatever, right? Let's say among those 4 tips, which will be the most important, or the one that you think that definitely helps you the most? Yes. Writing things in sine and cosine. You guys all agree?
Yeah, or just like rephrasing.
Yes. So as you realize, now sometimes you might figure that, I didn't have to do that, for a certain problem. You might be right. But I'll say that just by looking at that many, including number 8, I'll scroll down. The first problem, if you get kind of lost, I'm sure it might not be the best way, but if you write secant in terms of cosine, 1 over cosine, right? 1 over secant is just cosine, right? And go from there. You might be able to work it out. I'll let you know why you don't have to if it's multiple choice, okay? But indeed, number one, they wanted to, of course, it's kind of unfair, but they wanted to combine these two fractions, right? So that's the way it works. Number two, well, I've seen a lot of students realize, oh, all it takes is just either distribute a cosecant, or later on somewhere along the way, they change the cosecant into 1 over sine, right? And that just worked. Yeah, Noah?
If you get a chance, the other review right now,
Mhm.
not stuck in the question.
If I have time, I'll come to it. But let's say if you see question number 3 in FRQ, things are already in sine and cosine, right? What would you do to move on? Yes, even without knowing what you're supposed to get on the right hand side, you shouldn't really care, right? Just go find a common denominator and it'll work out somehow, right? Now number 4, I mean, yeah, it looks complicated. You know what? Sometimes people when they see those kind of things that deep down they know they need to avoid it, right? They need to expand it, but they will stare at the problem, right, without doing it, and hopefully that they'll figure out maybe a better way. This is like deep down you're resisting certain things you knew it's gonna work, but you choose not to do it. Does it happen in your life sometimes? Then you should learn the lesson, right? At least that learn the lesson in our class, so you don't have to pay for some, right? Or before, it gets too late, because sometimes, in your life, you choose not to do certain things, it'll come back to you in a hard way. So in this case, to be honest, expand it, right? However you want, maybe FOIL or perfect square trinomial, then you'll realize it'll be such a good combination of a sine square and cosine square, get together, become 1, right? And it cancels magically the denominator. Okay. Now, this one, hopefully you don't do anything crazy before you first take care of the sine and cosine square, right? Like I said, whenever you see them, right? Not to mention when you see sometimes just sine square or cosine square by itself, you should think about its counterpart. Sine square, always think about 1 minus cosine square in your head, right? Not to mention you get both of them add up to be 1, right? So people put, I saw it today, this morning. So people put 1 plus tangent squared x, because they realize sine square cosine square add up to be 1, right? Is that good enough? In my quiz, maybe I said, hey, do you realize 1 plus tangent square is also a Pythagorean identity, right? And then somehow I demand the students are going to write one more step. It's secant squared x, right? But in a test, we only get 1 plus tangent square x, right? Very likely you're going to start looking at which option matches that, right? Since I'm none of them, what do? You're going to have to think, well, it's not going to be this guy, right? Because I literally have 1 added to it, right? Well, that's scary, right? Third power of a cotangent, right? Then you see, oh, secant square. Is that possible? Yes, because you'll be memorizing those identities like crazy, right? So you should realize when you get to that far, it has to be secant square, right? This one is probably one of the worst, right? But people figure it out. They memorize how it works out and come back. I don't know. Maybe you guys don't want to tell me that. Well, Dr. What's the point of coming to you and we actually memorize how to work out these problems, and you actually give us the same problems? That's what I meant to do. So because is that what I told you? The same problem you're gonna get in a quiz, right? Because that's how you learn, in a lot of cases, right? And why do you think you have the textbook for classes? Aren't you just learning something people already told you what it is? You copy exactly what they told you, even the rules, even the answer, because we say that you have to get that answer, right? Because that's the only correct answer, right? But later on, you get to do something else. But right now, you work out a problem exactly the one we worked out and get them right. But in these problems, I do want you to try exactly the kind of problem, so you do get a confidence as you gradually building them, right? Anyway, so for this one, and it turns out that still, that little trick of writing things in terms of sine and cosine will just do the magic, right? Let me make the stroke a bit thinner because it's just bothering me. All right, so the top goes like sine square x minus cosine squared x. Even though it looks complicated, but don't do anything yet because you still have something else to deal with, right? So I'm going to turn cotangent into cosine squared x over sine squared x. So I guess that now you should have this kind of muscle memory. If you notice that you have complex fractions, right? Not to mention you have fractions that you could have combined, right? Before you do the keep gen flip, then you're going to focus on the denominator, right? So now the question is, how would you subtract fractions? We have a 1 there, right? You know that 1 is kind of nice to deal with. So you can just make whatever denominator you want out of it. Right? So you write 1 as sine squared x over, sine squared x. Then you get cosine squared x over, sine squared x. Now, again, just a sanity check. I know that I can make 1 become anything as long as you take the same thing divide by itself, right? But why did I go with cosine square over cosine square? That's still 1, right? Why I pick this particular form over the one I just told you? Because you want the same denominator, right? Like I said, there has to be a reason why you do something, right? So therefore, if you subtract the two fractions on the denominator, you get sine squared x minus cosine squared x. A big fractional line, right? Then you have sine squared x minus cosine squared x. Again, a fractional line, sine squared x. So now you can do the keep gen flip, right? When the denominator is a single term fraction. And I believe that you're going to write it as sine squared x minus cosine squared x. That's the numerator. Times the reciprocal of this fraction on bottom, right? So it'll be sine squared x over sine squared x minus cosine squared x, right? And you realize, oh, these two cancel, and that's how you get sine squared, right? I know it's a lot, right? But it's okay. So I'll get to that. How do you deal with multiple choices like that, right? This is not worth the work. Okay. Now this one again, you see that there are two terms, right? Need to be subtracted. Find the common denominator, right? Thanks to the 1, you should be able to do that real quick, right? And go from there. And last one, verify identities. You're better off to take the secant rather than to 1 over cosine. Okay. So now back to one of these questions. Let's say this one, right? You have calculators in the test, right? I mean, even though they say verify, complete the identity, but all you have to do is just pick an option, right? That works. I mean, wouldn't it be better to have x to be like a certain angle, the one that you know very well, right? Not to mention that you don't even have to do the algebra yourself. You know, the scientific calculator can type in the whole thing, right? But make sure that you know what angles you're dealing with, right? So what is in radians and degrees. So let's say, let's try some good numbers. Can I try x to be 45 degrees? What happens if you do that? Cotangent 45, well, tangent 45 is 1, right? Cotangent 45 is also 1. So you're getting 1 minus 1. That's the 0 denominator, right? So, I mean, it will still work out, when you get to calculus, but in this case, you might want to avoid those angles, right? So if I were you, why don't you take x to be 30 degrees? Plug in 30 degrees for x in this expression, work it out, see what it is, write it down, right? And all you have to do is just try 2 options, right? With x to be 30 to see which one it is, right? Maybe you'll see that, it works out to be letter B, right? Does it make sense? You need to complete the identity by picking the correct right-hand side. You know that if it's going to be correct, it should be correct for any kind of x you choose, right? So choose the easy number. Well, in this case, I mean, if you really choose 10 degree, it will still work out because you're not the one, right? Work out the algebra, it's the calculator. Okay. So please take the bounds of the calculator. All right, so now let me move on to type of questions like this. Okay. Now 15, unfortunately, I still see people are not very quick or sometimes even getting the wrong identities, right? So you need to remember, right? The sum and difference of angles, for sine and cosine, right? Once you expand sine alpha plus beta and a sine alpha minus beta, you will get it, right? But hey, it's still the kind of question that asks you to complete the identity, right? So now, if you want to choose some special angles to play with, let's say, what if I take beta to be 0? Because if it works out, right, it didn't say anything about beta, right? Beta could be anything, right? So what if beta is equal to 0? What do you get? Sine alpha, right? It's just alpha by itself, plus sine alpha, which is 2 sine alpha, right? But let's see, what if beta is equal to 0? If beta is equal to 0, type it in, right? See, cosine 0 is 1. You get 2 sine alpha, right? I know A must be right. So what about letter B, right? Cosine beta is 1. Cosine 0 is 1, right? So this is cosine alpha, right? This is 2 cosine alpha, right? What is this? This is sine alpha, right? I mean, there's still a way for you to just smartly plug in some numbers to try all these options, right? Which might save you a lot of time, right? But in this case, it's probably not worth it because it is an easy problem. But this one, seriously, I mean, I could work it out for you guys. But what you seriously have to do, if it's a multiple choice, try the numbers. Okay. Now you can try it now. What kind of alpha beta would you feel like trying? Would you set beta to be 0 as well? See how it goes, right? So we take beta to be 0. So, this is as easy as cosine squared alpha, right? Let's say, what if I'm looking at, option A, sine square 0, right? How much is sine 0? Use the calculator. You can't afford making a mistake like that. Type in sine 0, it's 0. Boom, A is right. See that?
We can also just do it all, right?
Oh yeah. If you want to impress me, write down all the algebra on there. All right. So I mean, you get the idea, right? But if you want to do the right way, so let's just expand everything. So cosine alpha plus beta, so it'll be cosine alpha, cosine beta minus, right? Remember that cosine flips the sign, sine alpha, sine beta. So that's the first part, right? The sum of the angles for cosine times cosine alpha minus beta. So it'll be cosine alpha, cosine beta plus sine alpha, sine beta, right? Now, before we dive into the math, please notice there's a pattern here. It's the sum times, it's the difference times the sum, right? So A minus B times A plus B When you forward it, you get only two terms, right? The first term is square root of a, right? Second term is square root of b, and they're subtracting. So why don't you just take that pattern and realize we have the first term, right? I need to square the whole thing. Cosine square, cosine beta, they're multiplying, right? Entirely gets the second power minus here. The second term will be sine theta, sine alpha times sine beta, right? Entirely square. You know that you can distribute the power over the product, right? So both sine and cosine gets cosine alpha, cosine beta gets the square. So cosine square alpha times cosine square beta, right? Minus this guy, the same thing, sine square alpha times sine square beta, right? So this is now when things gets a little bit hard to know, right? How to move on. Now here's the strategy. If you don't know what to what to do, then you're gonna have to look at the options, right? So you're gonna have that idea like where you're heading to. Well, we knew A is the right answer, right? But just know what you can tell in the test. So what you do is, let's say I'm gonna start with the letter A, right? Why would you go to the D, right? There's no reason. Think about what's the difference between what you have so far and what they wanted to get at the end. Okay, I have cosine alpha square, cosine squared alpha. They do have cosine squared alpha, right? So I'm good with this guy, right? Leave it. I don't have anything multiplying cosine squared alpha, right? I need to get rid of this guy. I have sine squared beta, which is right here, right? It is the sine squared alpha that bothers me, right? Okay, so now you think, if I want to have nothing multiplying cosine alpha, cosine squared alpha, not really nothing, it's 1, right? If you have a 0, there will be a 0 for the first term. So it sort of asks you to thinking about, is there a way you can sort of get rid of this guy, but make it a 1? And I hope that those keywords remind you that you're looking at cosine square. You hope you want a 1, right? Maybe you should do something about the Pythagorean identity, right? So now, again, it seems kind of out of nowhere, but I try to explain the reasoning behind it. So it turns out, you're probably going to hear people saying that a lot, right? It turns out cosine square beta is nothing but 1 minus sine square beta, right? So now if I make the substitution, cosine square alpha times 1 minus sine square beta, right? So I still have the remaining terms, right? Sine square alpha, right? Sine square beta, right? And of course, you know, you just have to distribute it, right? So you get cosine square alpha is the 1, right? Minus cosine square alpha multiplied by sine square beta minus sine square alpha, right? Sine square beta, okay? See that? All I did was just distribute the cosine square alpha over the parentheses and I get the first two terms, right? Do you see that? I did get the first term worked out perfectly like letter A, right? So I need to turn the remaining part magically into something like sine square beta, right? Do we have sine square beta? Yes. It's right there. And turns out that both terms shares the same factor, right? What does it remind you? One of the tips in verifying identities. When things have common factor, give it a try. Maybe you factor it out and that does the magic, right? But here, you know, if you can do, you know, even better than just factoring out the sine square beta, factor out the negative sine square beta. See what happens. All right, so if you take negative sine square beta out, can you guys tell me what left in the parentheses? The first term. Sorry, not the first term. The second term, right? Take this guy, including a negative sign, out of the parentheses. You're left with the cosine squared alpha, right? That's usually not a big deal. But the tricky part is, what is the last term? Once you factor out a negative sine squared beta, what do you get left? Sine squared alpha with a plus or minus? Plus. And now you see, oh, that happened to be 1. And therefore, it's indeed the form they want, right? But is it worth it? No, right? So that's why, I mean, you know what? Every instructor is gonna randomize the number, right? Get different versions. When I do mine, I'll look over to make sure that, if that happen to be a question, I haven't seriously looked into every single problem, but I did, for most of them, they're fine. If I see one of those questions, I would have speak up already, right? But I mean, it could be multiple choice, right? And I told you how to work it out, right? With almost no effort, right? Just take the beta to be 0 or take some easy numbers to work it out. Yeah. No. Well, no, I'm not even allowed to do that. If I only get to change the numbers. If the problem is a multiple choice, it has to be a multiple choice because I respect whoever made the test, right? All right, but I'll be sharing everything I wrote, today, like I did yesterday, right? So you guys have it, do some last minute review, last night, tonight. Now, before you go, guys, I need to let you know that there's so many students are almost getting a perfect score, but if in a real test, they would have lose 1 or 2 points in those problems.
You're getting 100, right?
Now, these problems, see that I put them all together. So look, they want you to figure it out: sine alpha beta, cosine alpha plus beta, right? The double angle, the half angle, right? So what I'm looking for is you write down the corrected identity, right? Double angle, half angle, the identity has plus or minus. You need to have it, okay? But now the problem is, that some of the answers might be negative, right? And some of the cosine and sine are negative. And this is why they ask you to think about the angle might be in some of the quadrants. So what happens is people might lose the point for, let's say in 28, they magically throw away the negative sign. They say, well, even the formula has plus or minus, radical, whatever. They choose the positive without telling me why. So yeah, I know I'm like nitpicking, right? But that's usually why people lose the point, right? So make sure justify your work, okay? Don't forget that word problem that I worked out, right? So you need to be able to solve the problem like that.